Associate Professor in the Department of Computer Science and Engineering, Rohini College of Engineering. Initially, you have to know what is a congestion control. Why in a network, why there is a congestion. So, look at the diagram. So, we'll be having a network where we'll be having a congestion, a traffic jam is depicted here. Then the satellite will be having so many number of interferences. And the feedback closed loop control, system to system communication. Then, so the closed loop control feedback should be frequent but not too much, otherwise there will be oscillation. Cannot control the behavior. The time granularity less than the packet may be lost, a retransmission, reduced throughput. So congestion collapse due to the unnecessary retransmission. Congestion leads to unnecessary retransmission of the packet, then undelivered, unusable. So congestion control in the internet will be having active queue management system. So TCP congestion control will be having adaptive increase and a sliding window mechanism. So many number of methodologies are applicable for congestion control. What are the causes of congestion in wireless sensor network? Due to the packet arrival rate exceeding the packet service rate. The arrival rate will be greater than the service rate. This is more likely to occur at sensor nodes close to the sink. So link level performance aspects causes such as contention, interference, bit error rate. This type of congestion occurs on link. So types of congestion in wireless sensor network: buffer overflow, link collision. So buffer overflow, so you will be having a buffer. So each and every node will have the buffer. If the buffer is overflow, that the capacity exceeds, so it causes a congestion. A link collision, so link may be break. Say link level congestion, it has such as contention, interference and bit error rate. Node level congestion, it is due to the packet arrival rate exceeding the packet service rate. This is more likely to occur the sensor node closest to the sink. So what are the effects of congestion? Energy efficiency, it wastes the limited node energy because sensors are very tiny devices. It has limited energy and power. So application of QoS, quality of service, degrade the reliability and application of quality of service. Buffer overflow, larger queuing delays, higher packet loss, degrade link utilization. It results in transmission collision if carrier sends multiple accesses used. So increases the packet service time, it wastes energy. Affects energy efficiency, it wasted the sensor node energy. In the application of QoS, the reliability and the one of the efficient parameter of quality of service. It degrades the reliability and the buffer overflow, large queuing delays, higher packet loss, then degrade link utilization. It results in transmission collision if it is carrier sends multiple access. Traffic control methods: end-to-end, hop by hop. End-to-end can impose exact rate adjustment. Data rate will be adjusted at each source node. Simplify the design at intermediate nodes. It results in slow response and relies highly on the round trip time. Hop by hop, it has faster response. Difficult to adjust the packet forwarding rate at the intermediate nodes because packet forwarding rate is independent of MAC protocols and could be variable. The existing transport protocols for wireless sensor network: protocols for congestion control, congestion deduction and avoidance, CODA, control and fairness, CCF, pump slowly, fetch quickly. Then priority based congestion control protocol, chiffon, adaptive rate control. Then trickle, protocols for reliability, reliable multi-segment transport. Then a reliable bursty conversion cost, even to sync reliable protocol. So Garuda. So protocols for congestion control and reliability, sensor transmission control protocol. So wireless sensor control protocol, SCTP. Each and every protocol will have its own strengths and weaknesses. So sensor transmission control protocol, queue length, implicit congestion notification, AMID like end-to-end rate adjustment, queue length, implicit congestion notification, stop and start hop by hop rate adjustment, queue length and channel status, explicit congestion notification, AMD like end-to-end rate adjustment. So CCF packet service time, implicit exact hop by hop rate adjustment. So packet arrival time and packet service time, implicit congestion notification, then exact hop by hop rate adjustment. Then the event if the packets are successfully forwarded, implicit congestion notification, AMD like hop by hop rate adjustment. Existing wireless sensor network transfer protocol wireless sensor network, congestion control protocols, reliability guarantee, STCP, CCF, siphon, fusion, then upstream protocols are STCP, then sensor transmission control protocol, then priority based congestion control. So we'll be having the source traffic and as well as we will be having the transit traffic. So it's a network node I, it's a network layer. R raised to the power I is RC. So R raised to the power to MAC layer, the network layer to MAC layer. MAC layer is in the data link protocol. So the intermediate traffic, the scheduler rate is R of I, that is induced in the source itself. So TAA power I, mean packet inter-arrival time at sensor node I. TS of I, mean packet service time at the MAC layer of sensor node I. Congestion degree D of I is equal to TS raised to the power I, TA raised to the power I. Updating, TA of I is equal to 1 minus WA multiplied by TAI plus WA TNP divided by NP. Both W and WS are constant factors between 0 and 1. Usually they are set to 0.1. So PCCB rate adjustment algorithm. Suppose P is a parent node of I. Periodically the parent node measures its congestion degree and informs to all its childs. So the RI and RC will be, it's a global priority will be taken, the scheduling rate based on the priority. If no congestion is detected, so the formula will be RI of source will be RI of SVC, SP of I divided by D of PI, GPI. If congestion detected, child nodes decrease their scheduling and route source rate based on the priority. So what's the problem arises when D is equal to D of 3 is equal to 0.5, there is no congestion. Both node 1 and node 2 increase their rates. At node 1 shall be having R1 SVC. At node 2 they will be having R squared SVC divided by 0.5. So although node 1 and 2 have different priorities, but they increase their scheduling rate and their source rate similar. QCCP PSQ, queue based congestion control protocol with priority support. So queue based congestion control protocol with priority support, the motivation is it does not provide relative fairness in case of decreasing congestion. So queue length congestion indicator, priority based rate adjustment, implicit congestion control notification, exact by hop adjustments. So the objectives are the aim to have better control on the sending rate of each child node, to provide better achieved priority and fairness for each sensor node based on its source priority, to prevent packet loss by controlling the queue length of each sensor node. So the components of congestion deduction unit, congestion index, source priority, rate adjustment unit, source rate, congestion notification to all the child nodes. The scheduler will be having the source node and the scheduler. So traffic from each and every child node is received, then it is based upon the scheduler, it will schedule it and then to the particular sensor node. Congestion deduction, the queue based congestion deduction intermediate node, two different fixed threshold, min threshold and maximum threshold. If there is a congestion, that maximum will be set. If there is no congestion, it will be less than the value of the minimum. So per child congestion index, the threshold minimum and maximum are defined. Normalized congestion index, suppose the sensor node I has Ni nodes, so it has N plus 1 I queues, Ni plus 1 queues. The congestion is increased when there is Ik of X, the congestion index decreases. Source priority, so source priority at the sensor node I. We define the total priority TP of I as the sum of priorities of all the nodes in the subtree rooted at the node I. So TP of I is equal to TP of J plus SP I. So tabulation results, we compare the algorithm with that of the protocols. CCF, PCCF, QCCPF is given. Buffer size. So can we design a protocol that reliably transport sensor data from many sources to one or more sinks without incurring congestion collapse? Can we design a protocol that reliably transports sensor data from many sources to one or more sinks without incurring congestion collapse?